बैटरी बैटरी प्लीज sit down.
वो जो हमारा चल रहा है तो उसमें देख।
Respected dignitaries, esteemed guests, conference participants, faculty members from various departments, and dear students. It's truly an honor to welcome you all in the inaugural session of International Conference on Frontiers in industry sponsor, Indian Office of Rikaku, manufacturer of analytical to extend all distinct from various corners of the country to be a part of this event. The presence today is immense countries have new interests. So this is here to explain and give some discussions on this theme is opportunity for each one of us to enrich, enlighten, and science. Without further ado, let's dive into our promising schedule. I would like to invite our esteemed dignitaries to kindly grace the respective places on sessions. Honorable Vice Chancellor, Professor Sukhdev Shukla, and Professor Research and Development, Professor B. Singh, Department of Physics, Professor Anil Kumar Malik, Organizing Secretary, Dr. Neeraj Pawar. To officially inaugurate the conference, I humbly request the dignitaries on the dais for lighting lamp of wisdom and knowledge. The lamp marks the beginning of this enlightening journey that we are about to embark upon today. हे शारदे माँ हे शारदे माँ अज्ञानता से हमें तार दे माँ शारदे माँ हे शारदे माँ अज्ञानता से हमें स्वर की देवी संगीत तुझसे शब्द तेरा आएगी तुझसे स्वर की देवी ये संगीत तुझसे शब्द तेरा आएगी तुझसे शारदे माँ हे शारदे माँ दुनियों ने समझी है दुनियों ने जानी वेदों की भाषा पुराणों की वाणी दुनियों ने समझी है दुनियों ने जानी वेदों की भाषा पुराणों की वाणी हमने तो समझे हमने तो जाने विद्या का हमको अधिकार दे शारदे माँ हे शारदे माँ ज्ञान से हमें ज्ञान तू श्वेत वर्णी कमल पे विराजे मुकुट सर पे साजे तू श्वेत वर्णी कमल पे विराजे हाथों में वीणा मुकुट सर पे साजे मन से हमारे मिटा दे अंधेरे हमको उजालों का संसार दे शारदे माँ शारदे माँ अज्ञानता से हमें तार
देखनी आपको टेप नहीं लगवा
A big thank you to all of you. Moving further, I request uh, we are delighted to welcome our chief guest, Professor Nagawat, whose presence makes us feel inspired. Recording in progress. Our Shripal and a token of our gratitude, shawl, and a complex moment. Kindly accept these souvenirs, symbolizing our respect and gratitude for you. It is said that great leaders create more leaders. On this note, I request Professor Anil Kumar Malik, Honorable Vice Chancellor Ma'am, for plant sacking and a token of our gratitude shawl and compliment. Your leadership and guidance have been instrumental in shaping this event, and we are grateful for your unwavering support. Moving further, I request Organizing Secretary Dr. Neeraj Pawar to welcome Honorable Vice Chancellor Sir Professor Pradeep Kumar Gupta, expertise, topology, quality, and approximation theory. Above all, please welcome him with a Shreefal plant sapling, a token of our gratitude, shawl, and conference memento. Following this, we move on to an important movement of today's session, the release of conference abstract book. This book is a compilation of valuable research and ideas that will be shared and discussed during these 2 days. May I now request dignitaries on the dais officially release. At this note, I would like to invite Professor Anil Kumar Malik to deliver the welcome address.
Thank you, Dr. Kavita. A very good morning to everyone present here. On the dais, our Chief Patron, Professor Sangeeta Sukla, Madam, Honorable Vice Chancellor of Chaudhary Charan Singh University, Meerut, a dynamic leader, distinguished academician, and an administrator with extensive experience in educational planning, institutional building, and research. His leadership which runs in university has reached heights in accreditation, NIRF, national and international. Her initiatives have consistently focused on advancing the quality of higher education, making Chaudhary Charan Singh University Meerut a model of academic excellence. Our respected Chief Guest, Professor Ashok Kumar Nagawat Honorable Vice Chancellor, Delhi Skill and Entrepreneurship. He has vast academic and leadership experience MP Mukherjee, Research and Development, CCSU University Meerut, Dr. Neeraj Pawarji, organizing secretary of this conference, listed as deans, probably deans, horticulture is here, several head of the departments, faculty members from various departments, speakers, and the most important, here and media person. Organizing committee, one heartfelt one view, research, science, technology, organized by the Department of Physics, Agriculture University Meerut, going to be held during March 4 and 5. Convener of this conference for me, welcome gathering. I would like to give a brief description about this conference. Key conference, research in material science and technology, propose a rapid advancement in terms of material science, harvesting and storage, materials for environment remediation, photonics technologies to transform industries, healthcare, and science and future. Whether it's the development of nanomaterials, sustainable technologies, innovations in material science and technology are having a profound impact across various sectors of environmental sustainability. Such technical sessions in the panel discussion, materials for sustainable development and photonics and quantum technologies. And that will be covered in this activity sessions includes materials for carbon dioxide conversion and hydrogen production. Materials, research, devices, magnetic and magnetic materials, rotational materials, or 2D materials, ecological materials, energy materials, optoelectronic materials, optical and UV detector, conducting oxides, etc., etc. Total 41 keynote and invited speakers are participating in this conference. These speakers are from USA, Europe. Some will be online. IIT Hyderabad, IIT Bhubaneswar, IIT Delhi, IIT Roorkee, IIT BHU, IIT Guwahati, CSIR, Delhi, CSIR, DRDO, CU, Jamia Millia Islamia, Afghanistan, state universities, uh, prestigious private universities as well. As we embark on this exciting journey of knowledge, exchange, innovation, and innovation, we are witnessing the coming together of some of the brightest minds in material science. And this conference promises a remarkable platform where cutting edge research, breakthroughs, and the future directions of material science are discussed. The diverse lineup of experts comprising the world renowned experts and researchers provide us a unique opportunity to learn from each other collaborations, states, innovations, new avenues, solutions for research and teaching. I extend my heartfelt gratitude to our chief guest, Sir Ashok Kumar Nagawati, Professor, Vice Chancellor, Delhi, Professor Sangeeta Shukla, ma'am, Honorable Vice Chancellor Chaudhary Charan Singh, University Meerut, Dr. Professor M.K. Gupta ji, Vice Chancellor, Meerut, and invited speakers, faculty members, and research scholars, and students for their unwavering support in making this event reality. I also organizing committee members and volunteers who have despite hard work have been ensuring that all participants to actively engage in the in all the sessions, panel discussions, and networking opportunities. This exciting event where this conference lessons and ultimate the advancement of the material sciences. Once again, I warmly welcome all of you to play. Let us make this event a great success. This work will be- Thank you very much.
Thank you, sir, for your insightful words and for setting the stage for what promises to be an exceptional. Now, for you to
Thank you, Dr. Kavita, and very good morning to all of you. It's my proud privilege to introduce our chief guest, Dr. Nagavar. Dr. Kumar Nagavar. He spearheaded the daily and university vice chancellor since July 2020. Prior to this, Dr. Nagavar has served as the director of at Rajasthan University. All in the first university of India, but for over 4 years. He has been wide one of the Dr. Gitaver, the renowned medical physicist, also is a high end. He has an excellent academic report, brings with him 35 years of vision, member of well-known University of Rajasthan. He has various achievements, five academic for with 19 years of academic experience. Dr. Nagavar has been as the member of Senate, coordinator of UIC and he significantly contributed towards connect innovation and innovation and and defended the concept which ultimately led Dr. Nagavar visions any skill and entrepreneurship university the unique and level which would be famed for its by creating a community of learners that promote excellence and make a transformative impact on society, the technological driven world. So, this is not speaking again.
thank you so much, sir. Now it is my great honor. I would like to invite our chief guest to share the wisdom and insights with us. We eagerly await for your words and guidance.
नमस्कार मैं आपसे Honorable Vice Chancellor, Honorable English, Professor Veerbal Singh, Director of Research, Professor Harish Kumar Malik, Pawar, dignitaries of the years, guest scientists, esteemed researchers, and it is all an honor and privilege in this event, International Conference on Scientific Research, Academic Science and Technology. I am deeply humbled by this great for an opportunity to share my views and opinions. All are actively working in the area of on material science and technology, and I have very little exposure in the same area. I am a physicist and a have different and material science, to my knowledge, is one of the area whenever the science is very first the attention is to the materials. So in our evolution history, what were planned to ourselves, materials were our concern. Maybe in the case in the beginning, only small and wood were important materials. Only was the material. But I'm aware that since then we have moved very much ahead. We are designing size materials. I'm aware of. I'm very happy to enjoy and choosing the physics, chemistry, mathematics. And biology. Why I was happy? Because I was told that I'm made of molecules and kind of vectors. And I was very happy that there were not only elements in the periodic table, number in there. So maybe master the knowledge of limits which are listed in the periodic table, then understanding of the nature. Because most believe in reductionist approach system. But very soon I realized that it is not a simple thing like that in nature. Nature is very complex, and you find that one can make a water molecule using principle one can then study the properties of the first shock which one gets when one has a basis. Properties of the actually hydrogen and the beginning of my understanding of the emergent phenomenon. Materials by reducing them into their constituents. Now, as a cosmologist, also we pay attention. Cosmology gives me an understanding of the universe mostly because 96% is not known to us and only dynamic matter. The material scientists are coming to the attention of that whole dynamic matter. At this conference, I am also reminded of the statement which I often quote and which in my understanding most, and that was given by this in a conference 1959, and which was mentioned in the book Understanding that as if it is a clock. And the statement was that there's room at the bottom. And since there's plenty of room at the bottom, Feynman said, future it possible to write the entire Metallica, which occupies many almiras that can be written on that small thing. Just before my birth, great visionary this is scientist also foresee of room at the bottom. So how much materials we can make? So yesterday I ran a query and how many materials we have yesterday and so on. So as about 2 lakh inorganic materials listed in the materials for the open data. That's a very good number. It means we know the names of the materials about them 100 or 500. As an exercise to go. I think it would be 500 already like names and organic material, especially material restriction database, organic, organic restriction. Very huge number, very impressive. It may give a wrong impression also that we have synthesized most of the material. But as you all know, science is also providing an opportunity to explore and learn about others, what of them. But if you understand made by the Richard Feynman, and there is plenty of room to, and that would be a revolutionary thing. I don't know that changes engineering and technology depends upon material science. Very simplistic view of engineering paradigm is that if you have materials, you can study materials, their characteristics. Once you understand the characteristics of material, you can make elements and devices. In my understanding, using elements and devices, making appliances, gadgets, machines, or any such product which can be useful, primarily depends upon materials. That's why mostly materials are the development will be so fast and execution is information. As a biological species also, DNA is also most material in which information has been stored by the nature and through evolutionary process. Our functioning is mainly given by the DNA, which is a complete computer in itself, as well as the biological materials are definitely very important for us. But how many such materials can be made? That paradigm, when you realize the number, and one scientist has estimated that number. What many people are active? You may be knowing the answer. But for me, it was quite shocking. No, I was thinking that millions we have already made. Our total population is about 1 million. and maybe 10 billion materials we will be able to make in coming period of time. One billion citizen living at planet Earth right now. So billion will be sufficient. Or billion possible number. Billion go further and etc. Then I go further and so on and so forth. But then I explored the literature. I came to know that it's not trillion. It's not even trillion. And it's not even trillion. Four times. It's trillion. Means power 60 as possible as how much we have achieved? Plus to power 6. Lot of way in life and deliberations which will take place in such conference will be shaping the future of humanity, future of mankind. And maybe the knowledge, when you study the materials and their properties and advances take place, we will be definitely in the able enough. We have technological tools to edit our genes and gene edited babies like just in the world. Very soon we will be in a species called that Homo sapiens have been named by scientists in biology. The Homo sapien would become a tribal one, and every Homo sapien is regarded as a tribe. We have a biological species called Homo erectus. And for becoming Homo erectus, we have to re-engineer ourselves. We have many challenges. But there. From the conference and recently I said that how many neurons we have in the brain and how many connections we make, and our intelligence is limited to that. Now that number is absolutely large. And trillions of access can take place inside the brain. Discover new material as well as understand the life which is complexity. Very soon, have to instead of trillion synapses, our brain size should grow. And if our brain size is such that it can make trillion connections, maybe that day we will be have capacity to understand and explore each of this 10 raised to power 60 possible uh, worlds going to be more complex, more difficult, more because of you working in materials. And the Higgs, but the still number is less than 100. And we believe that these less than 100 quantas and interaction between them can explain everything. But even if we know the fundamental physics, if all the questions are answered, the world of material science will not have even on that for long time. I hope and millions of years there will be a stop of pursuit material science. Also. But if India research will be left behind, India, we can't, we cannot see it. And I hope that the deliberation in this international conference would make you do more and to change the existing scenario. So let us work on this and with one quote that Yes, Marie Curie. Marie Curie, one never notices what has now it will be deliberated in the content what you have achieved so far. Marie Curie has said one never notices what has been done. One can only see what remains to be. And what remains to be done in material science is too much than what has already been accomplished. I wish this conference very success, and since I have a limited time, like speaking minimum 1 hour I need. Thank you very much to all the organizers and all the advisors providing me this opportunity to say something that happens. Rise is also due to some mechanics and some hormone that conference grand success. Thank you very much for patient.
Thank you very much, sir, for your enlightening words. Yes, have certainly paved the way for a meaningful and enriching experience at this conference. Honor and immense pleasure, would like to invite the Vice Chancellor Ma'am to deliver presidential address.
A very good morning to all of you. आप सभी को नमस्कार. Today's chief guest, Professor Ashok Kumar Nagarbaji, Vice Chancellor of Delhi Skill and Entrepreneurship University, New Delhi, distinguished speakers, eminent scientists, faculty members, young friends, students, press and media. It's indeed a pleasure for me to stand before you at the inaugural session of this very 025, placed by Department of Physics. So, at the outset, I congratulate the organizers, Professor Veerpalji, Professor Anand Malik, Professor Neeraj, and the entire physics department for organizing this wonderful event. Special guest on the dais, Vice Chancellor, Dr. Malik, by everyone. On behalf of the university, thanks warm welcome. Now, this conference marks a significant milestone in our continuous pursuit of excellence, mission, and research. I will say that we're living in a material world. Making things is a human trait and one that has been crucial in building the world around us. Talk about all the applications and key members of both modern world is concrete was a country would have been the largest emitter of carbon dioxide. Developing new building materials and thirds of concrete production was tasked with scientists and thus reduced emissions. Now, if we talk of bamboo, it's a durable, strong, lightweight, growing, biodegradable, some many useful properties of bamboo. Bamboo has been used in construction since centuries. Scientists and engineers have been exploring this material. Now we find utensils, furniture, of bamboo, as well as clothes and now cricket bats. Now keeping surface and equipment sterile in hospitals, and it's a huge challenge for all of us. This is why material scientist has developed anti coating materials that are resistant to heat. So you see how important this material science and technology innovation for all of us. Thus, frontier research in material science and technology involves pushing the boundaries of current knowledge, developing materials and technologies, address global challenges ranging from energy sustainability to advanced electronics, health, and environmental preservation. Cutting areas of research often interdisciplinary, combining physics, chemistry, engineering, biology, and technology. So I believe every student on this is how the material science is going to progress. This rapid evolution of this domain demands the collaboration, multiple this and transformative ideas covered. This conference will definitely provide an excellent platform for all the scholars, scientists, and teachers for sharing knowledge, presently cutting edge research, exploring new frontiers in this students' conference. I'm sure will bring something good, some potentials for us and for the generation. I would also like to highlight some of the key areas where sciences is being. We talk of nanomaterials and nanotechnology, carbon-based nanomaterials, carbon nanotubes, graphene oxide, is some of the most promising materials for next generation electronics, storage, and drug delivery. Quantum dots, nanocomposites, 2D materials, this is beyond graphene. Researchers are exploring challenges theories. Quantum materials and quantum computing is another where the students can think something. If we talk of advanced energy materials, the advancements in physics, liquid materials, energy storage. If we talk of biomaterials and bioengineering, material science is one of the simplest that with biological systems like biodegradable plastics, biopolymers, smart biomaterials, 3D printed tissues, and self-healing material is also this like research is ongoing still to develop materials that heal cells, expand and improve performance with that. Then if we talk of sustainable and green materials development, development of green material is crucial part of sustainable and mitigating climate change. Key aspects of green material development include biodegradable and renewable materials, non-toxic and safe materials, and many smart materials like mycelium-based materials, recycled polymers, solar panels, finally advanced manufacturing and 3D printing. Everything is so much to think. So learning is talking to your experts. Many esteemed scientists are present over here. You can come up with your own ideas. Overcoming these challenges requires collaborations, advances in modeling, novel manufacturing techniques to bring new materials to the market scale. I'm confident that this conference will find its solutions, least by society. At Chaudhary Kiran University, Meerut, committed to all culture, research excellence. Recently, granted and honored to keep it true. And 29% of research papers published by my university are in reputed journals with impact factor and with the highest impact factor of more than 30 points. 57.3 research papers have been published. One time journals. This is our great achievement. University has rich index of 43 that comes under this category. Average citation per research paper published by the universities. The university has secured a grant of the Musa Education Government of One and not the Plus University. Thus, this conference also reflects commitment to advancing science on carbon researchers as the challenges of the future. At this stage, I take the opportunity to extend my deepest gratitude to our chief guest, Sir Vice Chancellor, Delhi Skill and Entrepreneurship University, to receive this inaugural event with us and sharing his insights to you. Encouragement has inspired the young sitting in. I also extend my heartfelt appreciation to all our distinguished keynote speakers invited to this session, person those who are speaking in this session. Plus, the most important for me is young students, young faculty, and really want you to be a part of this conference with their ideas, with their discussions. This will undoubtedly enrich the discussions and congratulate the organizing team, especially and the entire department, reports and planning, meeting, executing, which is truly commendable. Thus, frontier research in material science is a wide range of possibilities for future technologies, addressing key challenges in energy, sustainable development of new materials, along with innovative solving as this we continue to collaboration between scientists, but it's crucial at this very critical point, and this promises a good future for all of us as we embark this journey of exploration and knowledge sharing. During these 2 days, encourage all participants to forge new partnerships and contribute to the collective progress of science and technology. And these organizers, as I was looking at their chart, almost 54 poster presentations. So I experienced 6 prizes for oral presentations also usually get some prizes and certificates. So this encourage our students and if the amount will become teachers because student gives you some very good problem, you can come up with something also. And this is what now. So very much for giving me an opportunity for few minutes. I declare this conference open.
Thank you so much, ma'am, for your inspiring words. Ma'am, your leadership continues to inspire, to guide us towards excellence, and we are privileged to hear you today. As we approach the conclusion of the inaugural session, I ask Dr. Manish Kumar to present photo points.
Thank you, Dr. Kavita. Inaugural function, FRMSP, and Nagavat, Able Vice Chancellor, then inaugural function, Professor Shukla, Able Vice Chancellor, Chaudhary Chan, Pro Vice Kumar Gupta, Research and Development,
Professor Convener FRMSP 2025, Professor Anil Kumar Malik, Department, distinguished keynote speakers and media. Very good morning to one. Extend my gratitude at the conclusion of the session of the conference on Frontier Research in Material Science and Technology 202. First and foremost, I would like to express deepest appreciation to our chief guest, Professor Ashok Kumar Nagawat, Principal Vice Chancellor, University, for valuable insights that have shared and inspiring on your words have truly motivated us to look at science differently. Thank you very much. Further, I to our Honorable Vice Chancellor, Professor Sangeeta Madam. I also want to thank you, ma'am, for your outstanding efforts in new heights. Under her leadership, under her able leadership, the university has achieved A plus grading, CPA of 0.66 and category 1 ranked is in India. Our university achieved 222 ranked first 125 rank amongst. The university has been awarded the best state university in research citation for 2023 Web of Science. Our university has published patents during last 3 years. And the estimates what university for us in leaders. A special note of gratitude to our keynote invited guests joined us online from US and Europe and who are personally present from BRC Mumbai, IITs, Central University, laboratories, DRDO, and private universities. Participation and in our commitment. I would also like to present financial support through our monthly AI technology Japan for generous support which have been instrumental in making this conference a reality. A heartfelt appreciation organizing committee for ensuring hard work in the scene and enthusiasm and engagement. Your presence here today reflects the importance of collaborative efforts in shaping the technology. Conclude my vote of thanks toward fruitful discussion and meaningful collaboration in technical sessions.
Let us move on this journey of learning and collaborations with words of Albert Einstein. Only thing interfere with my learning are these words wish you all enriching ahead. For signing of this section, I'd like to request everyone to please stand up at their places in respect of national anthem. Thank you very much. All the participants are invited for we provide very important three parallel technical sessions. One will be here, and second, three third session will be in of Department of Physics. Everybody join us to the technical session. Thank
हो गया तो करवानी है फिर से करवा दे ओए अब कर लिया ये करवा देगा कर ले
everyone, please,
फोन
you are requested to please join us for a group photograph. The conference photograph. Please join us.
सर बैठ जाओ जरा थोड़ा सा पूरा ऊपर आ जाओ पूरा फ्रेम थोड़ा देख पीछे नहीं आ रहा पूरा फ्रेम
session. Four oral presentations. The chairman of this session will be Dr. Prasant Chauhan. Dr. Prasant Chauhan did his MSc from IIT Roorkee and PhD from IIT Delhi in the area of laser plasma interaction, Center of Energy Studies in 2008. After completing his PhD, he received hyper postdoctoral fellowship from European Union and worked at Instituto Superior Tecnico Lisbon, Portugal for 3 years. In 2012, Dr. Chauhan joined Department of Physics and Material Sciences and Engineering, JIIT Noida, Sector 128, and working as associate professor here. He has guided 3 PhD students and published more than such papers, journal of high repute. His major research interest lies in laser metal interaction, particle acceleration, and request Dr. Prasad to please chair the session. Over to you.
Journals, delivered over 200 invited talk in the different international conferences, evaluated 67 external doctoral theses, which is a huge number, and it shows his expertise in his field. Professor Ahmed is recipient of CRSI Bronze Medal, MRSI Medal, SFG Bronze Medal, awards in the area of the physics and science. I invite him for to deliver his talk. Now, Professor Tobilan.
Thank you. Thank you, Chairperson, for the nice introduction. Very warm good morning to all of you. First of all, we would like to thank the team, organizing committee, especially Program Malik, Sanjeev, Nepal, for special invitation. I lecture for this conference. So, yeah, since this conference actually is based on the material science innovation, so the title of my talk is for the development of advanced material for clean and green energy. So this area, the particular area, is actually very left area towards the theme of this conference. So this is the research area actually that I deal with in my research. Actually, we are working at designing advanced and the functional materials to catalyst, and actually we are applying these materials for various applications. We are doing hydrogen production and by using the electrochemical, photochemical, water splitting measurements, then we apply these materials for functions. Actually, in organic conversions, as you know, actually, most of the organic transformations which are actually produce very valuable chemicals, the drugs, and most of these organic transformations are supported by the inorganic catalyst. And if you are able to transform those inorganic catalysts into nanodimensions, then actually this yeah, yeah, and actually you can our main line of work actually is have the number of applications. Million, multiple applications. In the hydrogen product, because actually see the energy crisis, and there are actually a number of factors for which are for the energy crisis. Limited renewable energy resources, growth, high demand of energy supply. There is a political kind of associated with the energy crisis. So hydrogen is the renewable energy, clean energy, green energy. And actually, crisis is like highly abundant, environmental free, and has zero impact over the environment. So we produce actually this hydrogen by water splitting. For that, photochemical and photoelectrochemical splitting, and all these technologies are collectively for all water splitting. So we can actually fulfill to produce green hydrogen to resolve the present energy crisis. What is simple chemical? You break water molecule into elemental oxygen, but splitting of water means breaking of water is not as much simple. Actually, it is not as simple as written over here because splitting of water two driving force. One is the presence of the conflict, and other make the economically viable process must have the solar light to actually produce water. So, if you get solar spectrum, you could see actually the visible light component is around 40. Have to design these advanced materials so that actually the bandwidth the actual visible light. So we have to design these materials that are having actually full bandwidth to the visible vision. So what we are actually doing for the designing of this material modification by doping of the certain metal ions over the host. But then they are heterostarch. Their optical band gap tuning to bring it to the and then we apply these materials for these kind of applications. So the basic concept actually is to design these materials to these they will apply make these materials viable for this kind of application. Now, what the experimental setup actually you can use for photochemical work. Need to design a material, specific amount of sacrificial agent and required amount of the water. Amount of the water actually depends on the volume of work. It's very much specific for this experiment and when you have actually all three components, then you need to mix in an atmosphere. Scientific. You contain the like activity, then gas. So actually the atmosphere should be there, right? To actually load this reaction, in the actual light source, just keep the light source you have to pick, with respect to the actually optical band gap of the material, and then actually when you exfoliate this solution with the light, uh, photogenic like of the conduction band, whereas actually valence band are used to both are like what oxygen. And the phenomena actually, these electrons will be as stable actually as possible for the other measurement. This is so the whole setup actually, it is actually installed in my research lab. I told you that it is the electrochemical water treatment. Chemical is the simplest method to know what the water is where you can use direct current. And actually, one electrode actually acts as the hydrogen evaporation reaction reaction. Reaction occurred, note the reaction, and when you transform these light source, this experiment is called as photoelectrochemical water splitting. But for that, actually, the electrode assembly you need to design in such a way so that actually this one actually, what are the actually sources of the hydrogen? They are actually natural gases like the requirement of the for production of the hydrogen. Talked about hydrogen, carbon dioxide. And as you know, hydrogen is of various kinds like green hydrogen, blue hydrogen, or the gray hydrogen. You are able to actually eliminate hydrogen, that hydrogen is called as blue hydrogen. But if you are not actually able to separate carbon dioxide from hydrogen, that hydrogen is called as the gray hydrogen. Uh, with these greenhouse gases like carbon dioxide, methane, and the gases oxide, they are world space temperature. More interested in hydrogen, and the electrolysis and the photolysis are considered as major. So most of the are working simultaneously along with hydrogen for this carbon emission issue. So are using for vehicles, and the world largest actually CO2 emitters are China, India, and the uh, are with this 2040. So the thought process of my presentation actually we are more oriented that we are designing the metal-free, cost-effective. The costing presently is around $6 to $7, whereas the industrial costing is around $6 for in this direction, so that actually we are able to reduce $2. So that actually the industrial costing should be around actually $1 to $2. And these are the actually experimental values how much actually hydrogen is produced from the water when you actually do this. So actually we are designing, we are working actually to make the binary and the ternary or the quaternary express structure by taking the support material, and the support material in these reactions are the carbon dioxide, graphene oxide, and the reduced graphene oxide. Action. So actually when you are working on the advanced material like heterostructure, kind of the heterostructure actually to structure this kind of maybe type 1, type S scheme or C scheme because this is very much useful. It will tell you of the actually transfer they are actually it will tell you the intensity of the conduction, right? Which actually gives the resulting this is level hydrogen. Actually, for my and cost effective hydrogen production. Because it's not doing there is no minimum. Are the actually graphene oxide, reduced graphene oxide or the graphite carbonate, right? That we are actually conceptual structure because actually they are very dependent for the environmental remediation. All these carbon supports are optical band gap. Since you are actually making the binary or the joining optical band gap tuning, your either oxides or your MCs, to make their tuning support. So, the binary or the binary have to give the synergistic effect band gap tuning and for for the hydrogen. And this is a very simple slide actually. When you actually design the material, so you can actually opt either the chemical methods or the bottom up approach. You will make the solution that you have particle you can condense. We are using. I'm having the both lab for the solvent polymer crystal cancer solvable reverse microemulsion. And actually, the strategy for the material selection actually is also very important. This is very important actually. You are actually more into kind of what would be your targeted which actually parameters or which property or which effect you have to target. For example, actually you are if you are in or the HCR reaction, these products need to have the uh, you have to look for the extent of the electron hole pair for the higher which actually must have the best surface area. Best surface area. You have to stabilize the material. Actually, some permutation of the established well for the so in this actually there are actually a number of these carbon nitride nanosheets. Uh, made these nanosheets of the graphite carbon nitride by actually anneal melamine around 540. Then the graphite carbon nitride, and if you extend to the human sulfuric acid or the human HCl, found found like and why we have taken actually graphite carbon nitride photochemical water. Excellent element of water. And we have taken this one as carbon support and design there. We have shown that actually how we are actually the quantification of the hydrogen. I will show in my uh, so before going to making the any material or any advanced primary application tech actually how to surface electron microscope and sometimes actually also uh, XPS or uh, so these are the actually techniques that is required to establish the primary before going to for hydrogen. Right? We have made the reaction. One set of reactions we have taken 5 phenol before going to the analysis of the result, I will tell you, I will share one point. The actually older industry, uh, but who was a single industry on photo, right? Because one problem I will tell you, usually when they make this, they take the actually sacrificial to actually support or the hydrogen production in the water splitting reaction. Do not actually check the quantification of the hydrogen, which is actually produced by on this sacrification. Two, one and one with the material. That quantification actually is required while actually putting these values in the table. So we have done this one. So these are the two. There actually have made this reaction. So here actually the triphenollamine sacrificial actually producing 470 micromole per hour per gram of hydrogen. Hour per gram. Then actually, uh, here actually I will show photoelectrochemical reaction. This is the electric load for the reaction and this one electric load for OER reaction and potential plot and this plot also frequency plot. Graph and low onset potential or the low over potential very effective action because it requires less voltage hydrogen generation. 100% for this specific carbon dioxide that we have this way. Now we have taken tried to design binary structure for this the hydrothermal method. And we able to produce the monophasic heterostructure. Then 28% of the copper ferrite was. And we have actually used the a number of techniques for the investigations like characterizations. I will not go into the detail because again everything is available. This one actually again we have used the mine as a certificate and 58% carbon iodide per gram of whereas actually the higher loading of the this is a limiting condition. Higher loading of copper sulfate, right, reduces the production of other tanks, which actually the best results actually we have reported and actually explained because of the non-polar nature of both the high affinity best providing protein sulfide. Maybe charge transfer. What kind of thing? Now, the first thing, EIS got no semicircular ring suggests for the actually the formation of copper ferrite or carbon leads to enhanced interface over the surface. What sort of plot for the carbon nitride, copper ferrite, and the then the what suggest for the uh, copper plot, which suggests for the PN formation for this copper ferrite carbon nitride, and here we see actually PN intensity decrease in PN intensity for 8% loading of the copper ferrite out of the carbon nitride, just for the low recombination of the hydrogen peroxide. They have given band mechanism. This is after band of copper ferrite as well as the carbon nitride before mixing, and then formula alignment. So the conduction band of tunnels to the the band of the copper ferrite. So this kind of the charge transfer, you can see this actually belongs to the included that the as prepared copper ferrite with the graphite carbon nitride is tied to junction. Now, electrochemical investigation. LFA plot for HCR, electrical corresponding to plot. Both all these investigations, just that no more potential over graphite carbon nitride. Not only transport also the active what is here before nearly 95%. This is again in this case we have designed the another hydrostat copper oxide or the graphite carbon nitride. Simple hydrothrough method you can replace and in 20 or yeah. So if you see this picture from the copper oxide and the graphite carbon nitride, they are very hexagonal form. And actually, when you mix both of them, uh, they theoretically they, there is actually structure or problem. Conduction band of the carbon ion more populated, which actually suggests that this nanotubes is more actually 2.5 millimole per hour per gram of hydrogen on the this quantum of 15% by taking this one actually copper oxide over the graphite carbon nitride. Very interesting is this OER and the HCI investigation. Iridium oxide. Here you can either they are comparable to the iridium oxide or some of the parameters are better than this. So we have reported for the this actually has prepared copper oxide nanoparticles over graphite carbon nitride or the commercial iridium for this kind of thing. We have revised the design actually. Which will kind of quantum dots by the dots. That's more you know, very difficult to publish. First mechanism have actually made three completions like 10, 20, and 30. What is the meaning of 10 or 20 or 30? Here actually the cycles actually known electrochemical in production. We have also actually shown for the ammonia gas. And so we have actually tested this material against ammonia, and we have other in the SS scheme for on TMOTU2 and SU2 and the quaternary hydrogen. Yes, the titration is very important. You must understand actually the basic titration technique for this one and then go for the hydrogen fraction. We have also shown actually the multiferric oxides. Actually, the multiferric oxides are those actually which show the magnetic supply. One help to 15. The multiferric oxides have shown these are very significant, have shown very significant result over the RDA fraction. And the second concept actually, when actually you do these experiments at laboratory, you generally use the like actually distilled water. But like, when we have understood not only building function, also for many organic transformation reaction. So we have actually tested these materials, kind of the applications apart from the hydrogen production. And now we're actually looking for some more advanced in my research. So, and to show there actually did some revision. Uh, and you in a new area, you must actually understand the literature concept, and you must actually publish the good number of the literature review papers. So here actually we have can actually adapt interesting or the good result. Uh, we polymers having some very interesting of large number of things. And these materials are all actually applicable not only for hydrogen but uh, for carbon dioxide. So yeah, I mean, I'm showing a different view. And is graphite. And then these are the actually costs of CO2 reduction, covalent pricing frameworks like CTA for reduction, and hypercosmic for right? Not only for CO2 reduction, we can also use these details for green hydrogen production also. So to conclude my, we have actually made the yes, on the electro. So if you are actually working on the carbon dioxide reduction, then the C2 or C3 or the higher value added products have the high market size. So you must actually invest over this one because this is challenging area because of the management support activities required. Only for us advanced material or layered materials are more favorable for carbon uh, this kind of the work, I must thank all the research team, my group, students, and my colleagues, Professor Mark, and my Professor University. Over this living area. So with this one, actually, thank you all for your kind attention. So
Thank you, Professor Pankaj. Although we are running late, but still we can have a question. Professor Pankaj, it might be a very simple question.
Sir, all questions are simple or hard. It doesn't matter, sir. Question is question.
Hydrogen, how much energy you can get from that 1 kg amount of hydrogen?
Actually, if, how much energy transformation actually is available? I have not. We are actually working on the quantification.
Why definitely water sources?
Air water, sea water, normal water, or
They
yes, they will show definitely they will show the different efficiency. Yes.
better efficiency seawater is
Desirable is sea water because actually its quantity is very high. We are actually in the laboratory where we generally work over the sea water. First, what and do these experiments. We have reported actually some reports on sea water with the efficient.
so let us try one channel and report want to thank you, sir. So after this wonderful talk, the next speaker is Dr. Sunil Kumar Kushwaha from he has done his MSc from Department of Physics, BHU, and then MTech in Solid State Material Science from IIT Delhi. He obtained his PhD in 2008 from a National University of Lahore. He is working as a principal scientist. He has published more than 100 papers, while 4 PhD students, master degree, and I did many research projects.
Yeah, so good afternoon. And first, I would like to thank organizer, especially Professor Anil Malik, Professor Neeraj Pawar, and of course, a special thank to Professor Birpal Singh ji. And thank you, Prashant, for your nice introduction. So, actually, already my friend Kabir has done so many things about energy. What, what, So first I will just briefly introduce these two-dimensional materials, and then I will focus this light-based hybrid structure for photo detector application. Then different these nanostructures, bismuth light on different TiSC2 and TiO2 for the PEC water splitting, and then of course some related to our what will be. So when we start with this 2D materials, of course, it has started maybe three, four, six, by this two third, yeah, basically they use this what these guys are doing always just and they do all the things. But they know the idea that okay, they will keep the layer and then materials grow. Yes, one atoms. One full nanometer. Maybe this are inaugural somebody professor that there is plenty of room at the bottom. Only the start really plenty of room at the bottom. And of course after that we can see we started this all the material like this. Right. Basically, if you go in the more details, like we have this, most of the materials like this, right, alphabetites, and then we can name like it, whether it is MOH2, MOH6, MOH2, or WH, all materials. And it is not like that we are going to stop here. As mentioned, like trillion now started the same, but in the future, started like this phosphorus elements, silicon, then put even what we have seen in even these materials are coming in the single layer or double layer, and they have the beauty. Of course, we can't work on the all the materials because it is huge field. So so of course again when we are going to see the fabrication process, how we are going to fabricate these coding materials. Of course, one is this top-down approach. Bottom-up approach. So in this case, of course, we can start with this atomic ingredients. And when we see this top-down approach, of course, this first material like it is material in the. However, it is not the process that when we want this to form large area, then we want the CVD process. CVD process is only for the shooting materials. Double layer of structures, and then again you have this different structure. Whether you can make this big multiple layer or you can make it shooting materials like MSC2, whatever you want, and make use of this. So one of the materials just I choose here that this is the bismuth light materials. That is the one of the materials of course that we started in the 90s, but very good thermoelectric materials. Consider it is one of the classical insulator material that is the use of what is going on this. They have chosen even whether this kind of materials can be used for this water splitting or photolysis. We have it as well. What that is using almost. So for the growth of the materials, we have the different techniques to growth, but here we use this most magnetron So what is the advantage of using the magneton splitting system in the way? Of course, it is very cleaner process. And all the process is happening. Like even if I go to area of the film, and of course, it's very low. It is a very relatively fine thing. Of course, so, as I mentioned, of course, we wanted to make this broadband photo detector. Why means what material we have to choose. Of course, one of the materials that is very important that is third lattice semiconductors. Especially when we see these third lattice semiconductors, especially we are talking about this energy gap. You can see from Indian capability, the lattice mismatch is very low. From the even other materials, the one of the advantage like even oh, indium or ammonium, what is in this range from one of the materials that for this building and building this solar, you see what is. So of course, when we see this market, these thinking photo detectors are available, but when it comes to UV photo detector, of course, this is because you can have the band gap of 1.1 in the convert, and that is when we have the CIO2, then of course it is going to so as photo detector, just for the basics, we can have this of course three different devices. But we can contact vertically or in the lateral contact when we can start. Another is this. Uh, this advantage like we are not going to put metals, but we have taken this MOSC2. As we have grown this MOSC2, this SCM supporting. And then we have done this Raman and XRD, and it is clearly showing the formation of the high quality of this from this given material. So later on, of course, we made the devices, and then we use the different light sources. We use this 250 like this is for and we can see this even for the only one device, you can what is another NIR, and UDP. More importantly, because we have them as a base, able to see even this for this UVC and UV area. That is the one of the work we already have this simple approach. We have this application of this coating materials in photo. Another, of course, as I mentioned, we also trying to have this Christmas on this metal materials, and then this is the process. I'm not going more detail. And then here we can, of course, we have seen this Raman all are showing the formation of Christmas. Even we have done this and high resolution this thickness of the also, as because we measure this and we can clearly and we can clearly see the polarity there. We can is without any bismuth sunlight. One is vertical and one is lateral photo detector. So even detectivity, we have measured this cycle for 40 cycle or even more than 100 cycles, and then it is more. So here again, when we have this Christmas and light, with the, of course, some materials have little bit. It is a normal approach or even the ideal approach to have this business and life for this. So already previous speaker has mentioned this PEC, so I just go in the more. But um, we have to find out which material is good and how, why it is good, because already known that following more than one material water splitting. And after that, we have this. So so our approach is to we have to move toward these flexible devices because when we have this polymer devices, of course, we can make flexible devices. Polymer and light are 2D material. It requires some light computer. So one of the approach that we can use is flexible metal pulp. These are the when you can see road fabrication. And this is the one of the approach this with vertical and the one the ideal case when we really want to use hydrogen energy for the transport system. So of course, in this direction, we have chosen this one of the materials that is we have this titanium foil. Then we have used our nano pyramids. Then after that, we have photo this on the type of this. Then XRT and Raman, XRT clearly showing the light and the ISU. This is the routine XPS measurement in which we can clearly see the formation of the ISU. More importantly, this TiSu2 material is one that is charge density layer material that we also need to study. Of course, we will have this behavior around 200 Kelvin. So that is the one of the behavior up to 200 Kelvin. So when this kind of property combined at room temperature, water is. Then we have so this means what we are trying to do here. Sorry. What we are trying to do basically we are discussing the properties of the material. Yeah, we are making this different heterostructures of 2D materials and the flexible thin metal foils for the different application, whether for these photo detectors and this water splitting, hydrogen generation, and all this process. This is the one of the example we have done this photo electrical. Uh, Even we have uh, this energy burn diagram, of course, it is again this finally connected to titanium metal coil, then it is promoting more. Just the part when we started this investigate TiO2, and then after that, a lot of then we are quoting this more. This is our TiO2 nanotube and the continuing metal file, and after that, the Raman and TiO2. And after that, we have quoted this MOS2 at the 700 degrees Celsius and TiO2 can clearly see the formation. Then this Raman is showing the layer spacing is too far. We have done this only without this MOS2, we can clearly see the current density is around 65%. But after putting this MOS2, you see the current density is almost two times more than the TiO2. So later on, we thought we can try to use some other materials. We have chosen this do this simple approach again. This TiO2 So here we have made this different nanostructure like TiO2 heterostructure. So this is our PTAC2, sorry, zinc selenide coated TiO2, and this is the field view image, and this is the zinc selenide we have coated. And this is our mental mapping, and we can clearly show the we have done this. So we have done this elemental mapping, so this clearly showing the platinum is located in more than then this is our TiO2. This AC2 coated. And then we have done this photoelectrochemical analysis of this material. Clearly, like when we have this only zinc sunlight, zinc on the 100 ampere per centimeter square, but the we are able to see almost 100. This is the one of the approach that when we are 60, we are to keep 1.5 per centimeter square when we have this hybrid structures. Course, we have done this all the analysis like what is the surface area and stability, and then finally this then this type two type two structures, and we can clearly see this how electron and holes are generating, and then because each has a band gap changing from plus percent of UV and this I just briefly discuss this importance of 2D materials and their application in the field of photo detector and what is and one of the approach that we have started that we use this titanium foil even, and then either we can make this TiO2, either we can make TiSC2 for the different purpose. And, yeah, I would like to thank the collaborators. Here, I will again. IT Madras, now, like to thank the director Venugopala Chandan, our HODs, my students, Ramesh, Dr. Subhan, Dr. Vishnu, Mr. Rahul, and Andy from the career and then CSIR first. So thank you for your kind attention, and I would
we can have a couple of questions. Dr. Sunil, one question. You have mentioned two approach, top down, top and bottom up and top down.
Yeah.
So this choice depends upon the availability of resources or application or requirements.
Actually, it is work both. So it depends on the what is the application. For example, when we are going for the real devices, it requires lot of the devices. When you are going for this kind of devices like energy production and all that, then still we can use this size of the devices are large.
And that
Yes, yeah. Yes. So, for example, we have this photo detector available, the UV photo detector. Using this, we can use this normal. We can use uh, this application or this we want a very high this robot radium garments. Then in that case, this gallium nitride will be more suitable.
Thank you very much for a wonderful presentation. I have a few technical queries.
Yeah.
So you have described a photo detector, three types of structures, vertical or
Yes.
MI.
Yes.
So which one is giving the best performance?
Yeah.
And what kind of wavelength of
Yeah. So here we have chosen this wavelength from UV detect UV to the NIR region. Broadband photo. Something like that. Going this person in the remote city. And then
uh, ABC3 range?
yeah.
So if we have to fix as one range, so what kind of filter you are applying for filter or just giving a single wavelength?
No.
UVADC.
We are not applying any filter. When we have only this without any coating.
We have fabrication etching system.
The gallium nitride we have grown photometric. More is-
2D material.
We have used again two techniques. If we want this not single or double layer, then we are using the maintenance system. When we want only two layer or
So regarding metallization, the Omicron,
yeah. So because when we are seeing this local
except
yeah, we have already done this gallium oxide. We have
I think AUV.
no C.
C.
It is going opposite.
Okay, thank you very much.
thanks, Dr. Sunil, for this wonderful talk. Kindly accept as a token of Next talk is by Dr. Bharti Singh. She is currently working as an assistant professor in Department of Applied Physics, Delhi Technical University (DTU). Dr. Bharti is PhD from IIT Delhi. Hello, am I audible? Good afternoon, everyone. Dr. Bharti Singh, presently assistant presentation. I would like to thank the organizer and Professor Anukim Malik and his team for giving me this my work that we are doing. So, the topic of my presentation is next generation covered by polymer materials or hybridized systems. Mm, This, this, this energy harvesting a lot and energy harvesting, but you can see in presentation, don't need to apply this vibration environment for generating a possible form of electricity. So, as we know that with the gradual rollout of the 5G technologies across the world, internet of essential for the industrial and the commercial development. And as we entered into the IoT area, mobile and portable electronics have increased in. These portable electronics will work with reduced power consumption. Definitely, these wearable electronic devices is a lot number. They are portable, they can be located anywhere. Definitely, they need to seek for some energy solution which is local, which is not mobile, it should be mobile. And it should be portable. These portable and the wearable electronics functions basically relies these batteries, lithium batteries that we know, like good to the environment because definitely we need to replace them after a certain period of time, and these batteries are not good to the environment. Solutions use the environment. So definitely we need to seek some solution. So what is the solution? The solution is we need to develop nano generator and device convert the energy which is present in the environment into the useful form of electricity. We already know this energy which are available in the environment is sunlight, the heat, and we already know that there is a lots of vibrations which are present in our environment. So the focus of the present the work that we are doing in radio is trying to harness this particular devices which we use for the smartphone that we have been the advantages of the would require replacement of the batteries. They are environmental friendly, enable new technology, so low operational. So these are various different types of energy harvesters. So the photovoltaic device relies to working on this basically converted into the good converted efficiency. But the type of management harvesters use convert into the electricity. When thermal gradient is however, these energy source, which we call also this source in the whereas from the machine we can have the higher frequency. We can tap those energy sources, convert it to the useful form of electricity, the low power devices. So what? So now because these energy harvesting devices, including vibrations,
electronic. What's the electricity in certain kind of so there are the various applications of the nanotube. They can harnessing the blue energy, harnessing the water. And they can be used for the implantable devices. As advantage is they're portable, wearable, implantable, easy to use. Okay. So as we need to harvest the energy by using something nanostructured material. So this has a certain specific property. So using harvesters. In the work that I am going to show, we should use the electric electric nanostructure. If one type of pen will be used, except for electric. It is not new to us. It was invented it is shown and by when we stretch the material, right? Some voltage is being generated at the material and this is a piece of potential. So there are two types of piezoelectric effect. One is the inverse piezoelectric effect. Definitely, there has to be certain unique conditions for the material to be piezoelectric. There should be uh, the, the amount of nature of the piezoelectricity is basically realized of high piezoelectric. So traditionally, the there are certain pair of concrete, zirconia, titanate. They have a good piezoelectric, but they are not good for the environment, and they have the brittle. They are also not flexible devices. Some of the piezoelectric phone and year 2006, the nanorods of this integrated nanorods they could not be used for the longer cycles. So recently, the new class of materials, the two-dimensional materials, that in addition to all these properties, they are mechanical. It has been predicted. The device. Another type of nanogenerators which can convert the vibrations into the useful form of the electric nanogenerator. To be understand by the triboelectricity, we have been facing this triboelectric effect in our childhood. We are pumping our air, the pump gets charged. This is contact electrification. So what happens in electricity? One of the surface gets one of the surface gets variety of material, whether it is two different solids, solid liquids, and liquid liquids. So once there are different uh, sliding mode, mode, and single electrode mode. We've been using this diagram. We are using two different materials. They are separated. Like the electron clouds overlap. If you bring the material, the electron clouds like overlapping. And in this case, there is a possibility because of the electron affinity difference between the two different types of material. The electrons can move from one material to the another, and those who are using the electron will gain those who are using to gain the negative. This is the mechanism for the electric. Father of observed this piezoelectric phenomenon that in 2002 the and since then we can see that there is a rapid increase in the number of applications that are coming to the piezoelectric nanogenerator because of the not nano generator. It has increased a lot in terms of mechanism like generating generator. So as we know that we want to use these nanogenerators for the wearable applications, use cutting polymers, although there are various polymers, we have been using this polyvinyl dichloride polymers, which is principally a ferroelectric polymer. It is a good property. So this PVDF and its copolymer exists in beta and gamma. Depending upon how the monomer change, CH2 and CF2 monomer units, and based on the different arrangements, like the trans, this arrangement, this beta and this is why our method is to increase this PVDF using certain kind of yes, the so, as I've already uh, as we basically predicted that there are these piezoelectric materials, they have good piezoelectric coefficient from like, we try to explore this mechanism in our nanogenerators, and that is why synthesize this good aggregated synthesize different kinds of polymers like MOS2 observe potentially make emphasis the good physical method of aggregating pure PVDF and this is R two-dimensional material. So, okay, so this is one of the other methods by which we have fabricated a nanogenerator. In which in this case we are using the nanofibers. The way of working mechanism of the piezo there is no there is no polarization alignment inside the material potential generated and because of this piezo release the stress the current uh, with its stress at the release side. Like this is the finger tapping mechanism and these are various materials or the film we have synthesized. This is the resultant film, this is the resultant nanogenerator, every layer and then electrolytic nanogenerator is ready. Tap the material to get the material. But the right molecule. In this, the having the MOSFP has the highest piezoelectric output. So these are the various results where we have tapped the material with a different frequency. We can see that at frequency output is highest, whereas after that it's reduced. This is the short circuit current of the different piezoelectric nanogenerator. And like the piezoelectric output, this use MOSFP. At the load resistance measurements as a function of the voltage because in order to supply the maximum load, power to the load, to have the matching, we have increasing the load, increasing current is reduced can be seen. Finally, we have seen by incorporating the materials, we are able to increase the generation of this. In order to use it systematic increase in the concentration of the materials, and we name these samples as like 0%, 3%, because these are the structural, morphological, and ferroelectrical studies of chemicals. The nanogenerators we have seen, because in order to have this output, to have a good this can be seen in inverse and to 70% have the interface enhanced. See with the graph, surface roughness also to be useful for storing the charge that are being contained. These are in terms of piezoelectric, the 7 to 8% concentration. After that, the accumulation of the dopant starts increasing, and that is the piezoelectric current, these are the voltage and current for the various finally, because we have seen that the output of the real time combine and create system. We try to use the TNG, fabricating the TNG, but we already know for fabricating a TNG, we need to create the layer we have chosen of the PVTF MOS2 is piezoelectric coefficient. That's when we use PVTF. In our calculating device, PVTF and the these are again the triboelectric output performance in terms of the voltage and the current, and we can see that the device having 7% has the highest electric, has the highest VOC, has the highest output voltage of 189 one. Again, because we are tapping the nanogeneric different frequencies, so we are seen in the case of the voltage keeps on increasing with the increased frequency because of the fact tapping the material with a higher frequency. That means the charges are being transferred. In addition to the force increase area, and it is directly proportional to the capacitance, and the capacitance is directly proportional to what we can store. So definitely with the rise in rise in tapping force, voltage of the nanogenerator is increasing. Again, the hybrid nanogenerator that two layers in a way that if we want to also have this device. This is the performance of the hybrid nanogenerator. The hybrid device having the two effects has the better performance properties. So this is again by combining the various contact forces, resistance. This is the output performance of the nanogenerator that the we have found that is the choice of the material that is also very important when we are deciding what to use. So here we have used polymer PVDF and PDMS. So we can see on this triboelectric series that they are very close to each other. So why not choose a material which is away from this PVDF? So one material having the larger blur, we have chosen this combined. We have and the current and this is very important to choose the right material for the panel generator. So these are effect of materials on power generated. This is the voltage and this is the power curve. We can see for the nylon, the power delivered is maximum. Yes, CFP is like more negative CFP from this giving is negative MOSC2 travel. When we are moving from PTFE to PDMS, we can see magnitude of the surface potential that has been simulated by the console is increased. This is a result mechanism to getting the best better output of the film. There are various real-time applications that we are doing in the laboratory. We are doing various, we can place the nano generator over various body and we are from the nano generator for the biomechanical to power water splitting system where we are utilizing the output of the nano generator. There is a hydrogen at the recent one is used ENG, all those nano generators we are fabricating definitely why not to use these TNG as itself is a motion sensor. So by placing this motion sensor, we reduce the power consumption. So we have made a nano generator. I don't know. Okay, that was my last slide. So in that nano generator, एक minute, sir. Just give me 1 minute. The animation will work. So we have by using the Arduino, we have used nano generator for the motion sensing and where when we are basically if a person is moving on the nano generator, that nano generator is passing some signal to the power management circuit information. And that receiver is connected to a light sensor. Signals that is will keep the light available in that room. So these type of devices can be used for the like the for no? So I think so this like to um, this needs like I would like myself because of this and thank you for your patience.
Thanks, Dr. Vasu.
Any questions?
Thank you very much, Professor Bharati. A wonderful presentation. I really impressed about your output. Yeah, this is simple because you are asked. I have very small system. Have you tried to transform the real device like we have to use in our hands, tools, and so on?
We are not able to use it in any so so not yes, we are able to use these nano generators for the optical applications. Like you can see for the various we are not using this like the wearable applications.
So you have working like 2D, 3D, and 3D.
We are trying
So you have optimized all. So what material you distribute that we should go that way.
because like yeah, because theoretically it is predicted that 2Ds are good materials and they have a aggressive piezoelectric effect. And then after studying a paper from a group, we found that when we are growing the genus structures, means what are genus? So that MOS2 and MOSE2 they are transition materials alkylate. Replace one of the material to another chalcogen to the end-plane piezoelectric. So that is why we try to choose. We have seen good things in the output when we are moving from molybdenum sulfide, and we have also used the tensile very very good piezoelectric coefficient. Also, I could not. Definitely, we have seen the people are using magazines in this case. We have been using the same material because one of the electrode we have fixed. Right? In piezoelectric, we just need a layer. We need the two electrodes. Just sensing the material generated on the opposite surface of the material. But we have fixed one of the material. We are just changing the other layer for the piezoelectric. Definitely, we need to have the two layers for the piezoelectric. So definitely, because we are working on because of the amount of current. So we are working on the power management circuit where we can boost at the cost of the voltage because we are getting a very very high voltage. So we are working on the power management circuit where we can boost the current cost of the working in this lab.
So what we want is without charging, we'll take when it's something corporate like that.
You mentioned that BMC and
Yes, yes.
and in
No, sir. For the triboelectric nanogenerator, it keeps on increasing as we increase the frequency because of the fact if we are tapping the material at high frequency, the charge gets transferred at a higher rate. So in the case of a triboelectric nanogenerator, it's increasing with increasing frequency. However, for it's not increasing this correlation.
of a material.
Yes.
What is the dimension of it? Is nano dimension of sample?
No, the diameter, like the x and y of the sample, we have taken 2 centimeter by 2 centimeter.
Too much VOC. So is it possible just like a solar cell, solar panel? We had put solar cell.
Yeah, definitely. So ultimately,
For appreciation. Okay, next talk is by Dr. Sunil Kumar. Sorry, Sushil Kumar. I'm very sorry. He's a professor of physics in Department of Physics, Chaudhry Devi Dayal University, Sirsa. He is working as a dean and director of different centers at the university. Which more than 8 papers. That 14 research scholars are currently working in the private private conferences. Dr.
Hello.
Maybe
First of all, I would like to thank the organizers of this esteemed international conference, Professor Anil Kumar Malik, Professor Birpal Singh, Professor Neeraj Pawar, and others of Department of Physics, Chaudhry Charan Singh University. So the topic of my talk is reduced graphene oxides is photocatalytic activity employable in environmental remediation. In my presentation, it is mainly for the PG students, for research scholars, studying life experience science. So the outline of my talk is introduction to nanoscience and nanotechnology, classification of nanostructure, characterization tools, RGF supported metal oxide nanohybrids, and recently we have published a paper in Material Science and Engineering and other hybrid oxides nanosheets. So as for that, phenomena and manipulation of materials at atomic or molecular scales, where properties differ significantly from those at large. Nanotechnology is the design, factorization, production, and application of devices. Nanotechnology is a great bulk materials and the systems at atomic or molecular scales. You know that the carbon is a very wonderful material and it is a versatile class of nanostructured material. far as the nanostructures are concerned, nanostructures have at least one dimension less than 1 millimeter. And we know there are zero-dimensional nanostructures, and there is one-dimensional nanostructure, there- and there is dimensional nanostructure, one-dimensional, three-dimensional nanostructure, or we may call it as zero-dimensional confinement, or we may examples are bulk or polycrystal. We know that a carbon found in all these four systems. Talking about fullerene, which is a superconductor, is a two-dimensional system. When we are talking about carbon nanotube, then it is one dimensional. In two-dimensional graphene sheet, it is we know that it is have high electrical conductivity. And when we are talking about the graphene and graphite in bulk material, so depending upon the structure, the geometry, and the arrangement of carbon atoms, very fascinating way, we get all these zero D, 1D, 2D, 3D carbon material. Which is nowadays so able. Now, why nanostructures are different? Results due to which the materials have demand is significantly different from bulk counterparts is one is quantum effect. So under quantum confinement conditions, electron energy states suffer alterations in resistance with a so materials in a flux. And the second one is the surface effect, is large surface to volume ratio. With the decrease in the size, the friction of subatoms increases high average binding energy per atom, and these variations causes size of the material. So in BSc, we study from one dimension potential, two dimension, three dimension potential. So these 0D, 1D, 2D is nothing but examples of the potential. So how to get nanomaterials or nanostructures? There are two approaches, Moplam and Mortimer. In our laboratory, we are applying the Mortimer and hydrogen method. So the characterization rules which we are dealing with our structure, microstructure, XRD, XPS, and so radiation. Here the reaction is taking place for wastewater treatment. And some important properties and applications of nanoparticles, because we are using here the hybrid structure of metal oxide, and reduced graphene oxide. So first of all, we are talking about the silver has distinct advantages over other metals. Silver has the highest electric material. Silver is also well known for its antibacterial and antimicrobial properties, and low is found in a range of particles. Silver nanoparticles have the ability to enhance the characteristics of by antimicrobial and antibacterial efficiency. Silver nanoparticles have potential applications in diverse fields as photo accessible. The important feature of silver nanoparticles or silver nanostructures photocatalysis is versatile and this will more gradually. With the grateful seriousness of the we know that graphene is a wonder material which is lightest and thinnest in the world. And for the discovery of dimensional graphene sheet, Nobel Prize physics was given in 2010 to this and first globe. So graphene is a carbon sheet, one bit, and has a hexagonal lattice. Yes, it is hard So the graphene has two derivatives. One is graphene oxide and the other is reduced graphene oxide. As the production of these derivatives on a large scale is simple, graphene oxide, it is the oxidized form of graphene and is known as graphene oxide. Graphene oxide is heavy presence containing functional groups such as carbon, carbon groups on a scale. Reduction the reduction, the RGO contains residual oxygen. So the higher the carbon to oxygen ratio, the more similar the properties of reduced graphene oxide of pristine RGO. So high large surface area, which almost restores the extremely high surface area and electric cells. Graphene, we may get the graphene oxide and reduction process, we may get the reduced graphene oxide means the reduced number of groups. Now, methylene blue, here it is taking the pollutant and a synthetic dye. One of the examples of organic produced by in paper, clothing, and color industry. And the industry builds wastewater. And it is harmful to flora and fauna of the universe. It also kills, uh, deteriorate the human health. Conventional wastewater treatment hardly suggests hazardous content. Catalyst an essential of the degradation of society. Dye molecules absorption rate of on the catalyst optical absorption capacity have impact on the rate of photocatalytic process. The decoration of metal nanoparticles on RGO cells reduce the of photoindustry electron hole pairs because graphene provide high and several functional groups with oxygen labels absorption of various ions and organic molecules by static and electrostatic interactions. Another important material which we are using here in our nanohybrid system is the titanium dioxide. It in anatase. Anatase is tetragonal. And it is the tetragonal phase is stable by rutile and rutile. So the important properties and applications of the titanium is it is inexpensive, means cost effective. It is chemically and thermally stable. It is non-toxic and it is competitive and hence it may be used medically. It has a bank energy of 3.2, which is light. It is used and it is a good UV light absorber. It has good oxidation and photocatalytic capabilities. It, so far as its applications are concerned, it is used in photocatalysis process. It's used for environmental waste of chemicals, pollution. It is also used in cosmetics, like sunscreen. It is used in photovoltaic solar cells. So the route which we have adopted in cases of samples, we have sourced the steel or the iron. Hydrothermal reaction is a heterogeneous chemical reaction in which the presence of a solvent, aqueous or non-aqueous, above the room temperature. In a usual reaction, the mixture will solution gets best. So these are the methodologies have adopted for the preparation of nanopart and iodine nanowires for nanohybrid silver nanoparticles, titanium dioxide nanowires, and RGO MCs. So far as the description of the state, we get here the Brookite structure of TiO2. The peaks are shown over here. So the pattern of graphene is normally exhibited as sharp destruction located and it was replaced by a equal way of reduced graphene oxide. The average crystallized size is 27, 32, and 42 millimeter of the nanowires, AgTU2 and AgTU2. Now, elemental composition and chemical state of the nanocomposite is determined by silver 3D doublet peaks binding energy is located in metallic titanium 2 half peaks at 4 respectively. Oxygen one has peak found at positions which is assigned to the net oxygen. Carbon one has exhibit peaks with binding energy at 283.89 and 283.9 carbon in RGO. Double bond C and oxygen double bond C and oil. It shows the microstructure of particle TiO2 nanowire and RGOC. The EDX images of this nano hybrid is shown here. Here we get the carbon, titanium, and carbon found here due to the samples carbon coated samples. Now this is the representative cell image and the corresponding element titanium, oxygen, and carbon. That titanium, silver, oxygen, and carbon are dispersed in the sample. This and a short-term image AgTiO2 nanoplant. The silver nanoplant RGOCs and the provides are clearly seen in the picture, and we have calculated the interplanar spacing here 0.5 and 0.236 nanometer, which matches and with 101 plane of graphite and 11 plane of FTC silver nanoplant. So far as the optical absorption study is concerned, we see over here that in the nano hybrid, the optical absorption increases. As well as we see here that there is a reduction in the bandwidth 3.2 to 3.2 because it corresponds to the UV region and visible region. And we know that in the solar spectrum, only 45, 46% lies in the visible region, only 7% lies in the UV region. So our tendency or our effort is to make cell hybrid in the visible region of the sun, so that the maximum light, solar light degradation process. And here we see that the luminescence spectrum. We say that the intensity of the peak decreases as the nanohybrid is formed. It means that the photoluminescence spectra that it is a combination of electron hole pairs, or in other words, we may say that there is a separation of the electron, which is an important fact to be achieved in the photocatalysis or photodegradation of that photocatalysis, which is used in degradation efficiency is defined by this formula. And here we see that the degradation rate of silane blue dye in the presence of this the light irradiation for 100 millimeters CO2, it is 59.5. So while it increases means increase uh, band gap is reduced, optical absorption increases, and when there is a separation of the electron and hole pairs, they promote the efficiency of the photo degradation of the dye in the presence of dye. So this is the shows the reaction mechanism in the photocatalysis process. Here, the superside radicals and the super hydroxide radicals are formed, which with the other dyes, that carbon dioxide and water are. So this nanohybrid aging the particles value to nanowires, RGB nanoseeds, So becomes very effective for the degradation of the organic dyes in wastewater. So far as conclusion is concerned, hydrogen ethanol used for production of TiO2 hybrid, XRD reduces the flow of TiO2, and images removes while are decorated on the surface of our geosix. For the nano hybrid as that of pure TiO2 nanowire, AG loaded TiO2 nanowire, we have the lower photoinduced electron hole recombination rate, which is essentially a requirement for a under light irradiation, decomposition of ethylene group is hybrid and the TiO2 and 2 TiO2. It is likely that and as well as good absorber of methylene group type molecules. So the photocatalytic performance of AgTiO2 argued and hybrid was found superior to this and hence used effectively and efficiently environmental remediation to waste water. So these are few series which we have synthesized, analyzed, and applied in our lab. One is protein analysis and RNA nanocomposite. Other is QDOP, Qdivium and ytterbium code of TiO2. And other is molybdenum dop glucose particles and NBTA code particles. And that is CE and D code of TiO2 particles. Nanocomposite. In this year, we have taken different catalysts in our lab characteristics which are to be required, which are desired. One, it should be cost effective. Number two, it must have less time, degrade the material in a shortest time, and its efficiency is more. So these are the few series of materials which we will use the photocatalysis. Although we are having other series also, but due to lack of time, we will take it later. Thank you.
Thanks, Professor. Professor, you have mentioned that CO and O. Duration of AG is with time is more with respect to gold and copper.
So we have tried the different series of materials. We'll see here that to get the final goal must be inexpensive, cost effective, so that we can use it commercially. Number two is that it must have degradation efficiency. Third one is the time interval. It must have less degrade the on these three parameters, where which one is better? Either it may be efficiency may be more, but it may be costly. It may be costly. Okay. Less costly, less efficient. So on these three parameters, one may take less time, one may take more time, not costly. It's more. It's like
Kindly accept our gift. Appreciate it. Okay, so next oral talk is Dr. Monu Mishra. As we are running late, so try to finish in 10 minutes.
So, good afternoon, everyone. My name is Dr. Monu Mishra. Dr. Kam lagate hain usually. So I am at present Assistant Professor of Physics at Gyal Singh College, University of Delhi. And today we'll be talking about surface state induced catalyst free CO sensing at gallium nitride and aluminum gallium nitride by gallium nitride microstructures. So this is the going to be theme of the presentation. We'll talk about catalyst free because usually when we fabricate a catalyst, reading notes we use. So I'm going to use catalyst free to CO sensing using this. First of all, why do we need a gallium nitride for question comes to by gallium nitride and nitride. So first thing is gallium nitride is a very wide band. It's 3.4 electron volt. To see the silicon is just 1.1 electron volt. It typically lies in the IR region, not cover all region. Second thing is about the electron voltage. Want to you want to 100 watt charges. Then if you want to make a charger to 150 watt to 200 watt, then you have to use hybrid. Second thing, why do we use gallium nitride? Because it is chemically stable. You can dip in water. How issues are compatible with high electron voltage, high temperature tolerance. That's it. It is now compatible. Obviously, I have mentioned both of the things. And it can be used by two forms. The one is you can make a FET sensor process. This process is such that it is a based device. It's one film. You're good to go. Okay, one we are concerned about CO2 because the most dangerous enemy is which you can access here. Unlike that, in the case of ppm level, you get a slight yeah, concentration increase and it does binds with the hemoglobin of your blood, goes to all part of the body. Silently, you get oxygen deficient and you die. That's what happens. Poisoning. But according to WHO, the safe limit is if you can make a sensor of up to 100 ppm and detect it within 2 3 minutes or maybe 1 hour. So this is what we have done. We have grown gallium nitride films. As you all know, I mentioned oh, nanostructure. Nanostructure is by surface area. One has like flowered gallium nitride. Flowered because usually gallium nitride is known on highly there is a distribution density. Many times this density takes the form of flower on the surface. So you by changing the growth parameter, you can easily grow different kind of nanostructure. Playing around with the latest playing around with the density. We have also grown some nano flower aluminum gallium nitride. So we have already grown gallium nitride for aluminum and then here is the interesting thing. If you see we did I am not going to show much results here which we have done using XMD. The sensing is depend on surface history. We're talking about surface chemistry here. The planar gallium nitride, ammonium gallium nitride, and aluminum gallium nitride of nanoplanar. The ratio of gallium nitride to gallium oxide varies. There, of oxygen is on the surface. Oxide is there, of oxygen is there. You have oxygen there. And if you can see, we can differentiate into three types of oxygen on the surface. Then by deconvolution of oxygen 1s4 level spectra using such as previous slide. So on the surface of gallium nitride, you get and further is hydroxide because when you are taking from the air, oxygen is very low. Absorb of oxygen. Uh, and interestingly, I want to highlight that this kind of oxygen is CO sensing. When when we have grown this thing, we put some chromium gold contacts with an anti-VRAM 4 into 6 millimeter. This is typically our IV characteristic. Here you can see as we are going from planar gallium nitride to nanoflower aluminum gallium nitride or nanoflower gallium nitride, your shortly measure height is increased and your surplus diode. Now coming to the main thing, it is sensing mechanism. Oxygen is a CO sensing on any surface, right? Depends on physics oxygen, in physics option, chemical option of CO on it. So typically, if you see two species which you have in the surface, one molecule comes with comes electron, converts it to CO2 and releases one electron. In that one electron reduces its resistance. Here you can see similar thing has been happened. Change in resistance, dip in the resistance, and with different temperature. We did the same thing at room temperature, 100 degrees. Highest efficiency of 33% in nanoflower aluminum. Why? Because in the case of gallium nitride, we have one species on that. And in the case of aluminum gallium nitride, we have six of oxygen on there. Another oxygen is already aluminum. So, it's higher efficiency case of aluminum gallium nitride. Also, highest, highest 100. And also, if you can see the device, response and recovery time, it was 90 in the case of nanoflower aluminum gallium nitride. What is associated with present? But I want if you are going to fabricate a sensor, try to make a nanostructure surface. Surface the sensing is going to be affected by the surface chemistry. Bonds are there. And here we can clearly see in case of flower and wood and this function is separate from 94 seconds. We also try to do cross sensitivity. When we make a gas sensor, the question is okay, it is reacting to a gas, but is it reacting to a different type of gas? We also try to see, NO2 is maximum distance, but it was not as good. The main question of this is not
getting higher efficiency, getting even high sensing handles, how we can manipulate our sensing. Okay, so cross sensitivity also we can change about H also play with this cross sensitivity. You want to make particular gas sensor reactive to a particular gas as well as temperature. Only it will be more specific and selective to a gas. This is all about what we have done. This is the first step of CO sensing without using catalysis. This is the first step. We can use a catalyst. We can go on efficiency of 300% with that. But that was not the aim. Aim to get the thing is to how that sensing happens because of the species, and we got a meet responsibility of 33%, and the time was given. What we are further willing to do is to optimize this performance 300%, 400% work on consistency. While this we are going to as well. Is there any questions?
Thanks, Manu. One question. You have mentioned sensitivity and response time, recovery time for different samples.
Yes, sir.
All these things also depends upon the particle size.
More, sir, the react response time and time device area is 4.6 millimeter. By changing the area, everything will be. Because I want to make it area. Anyone else?
सुधांशु को ले लीजिए सुधांशु को ले लीजिए
Okay, so next talk is Dr. Sudhanshu Gautam and PL Devi.
Hello.
Sudhanshu, 10 minutes.
Okay. Good afternoon, everyone. I am Sudhanshu from CSIR NPL, and I am here to present my work entitled Magneto-Transport Properties of Pristine and Chromium Bismuth Cell Light Topological Insulator. Thank you. This is the outline of my work. This is the details growth of aldo, the growth of coordination. Topological insulators are the new state of quantum materials. They are robust, are protected by and induced by different schematic of a topological insulator in which is insulated while the surface states are conducting. And this is belt with a certain belt cap, what kind of and the surface state of these materials act as a metal. Where the conduction band and conduction band and valence band uh, are merging and there is the 40 topological insulator in which
They have the conducting edges, while in 3D insulator they have the systems. To now, LCD uh, 7, and while the 3D topological insulator includes bismuth cellulite, Sb2T3 cellulite insulator, and we have chosen bismuth cellulite because it's only gold. Now, these are the applications of topological insulators. Topological quantum computing and magnetic memory and storage devices. Now, there are many good processes of bismuth cellulite, but for the material, it is critical to make thin films of these materials. And the bismuth cellulite topological thin films are mostly uh, local and good uniformity. Now, this is the experimental technique which we employed a combination of techniques to deposit high quality topological information in which a magnet followed by in which we have to perform a simulation process to maintain this business relationship important in the topological insulator uh, by the process of co. Now these are the characterization techniques which we have used in this one. Um, from here, actually, starting for uh, one among is for structural analysis, for its morphology, like AFM for its roughness, of transport, PMS, and like by doing proper masking, deposit electrons on our this was a light thin film. And now, then this film uh, uh, measured in this PPMS system in the temperature range of 300 Kelvin to minus now. Uh, first we three business very have thickness of 40 nanometer, 80 nanometer, and 160 nanometer. This is the crystal structure of bismuth cellulite in which we clearly see the stacking of multiple layers and each multiple layers and the approach of clearly when you put a line profile across the edge of data of one, when we do the line profile, we found that our multiple layer layer thickness is around close to this was a like multiple layer. And for
element from the surface of simple surface of point from the surface of simple. From so that our film thickness is about 50 nanometers. Now these are the magnetic transport properties of these supercellular films on sapphire substrate, and this is the schematic of our device of which by which we perform our four probe measurements. And from here, these all very different thickness. Uh, rest- on the very- very- the high resolution. And all of these, the resolution takes up after 25 Kelvin. Now A, B, and C. This is the magnet constant data of in the magnetic field of minus two Tesla, and we can clearly see the plus of the smart data when of some localization attempt in this. And this is the excellent we have we have determined the alpha value, which is alpha value is number of transits in the and for alpha value 3 1. These are the growth parameters of bismuth cell line films, which we have deposited in H2O substrates. So here we have deposited two sets of bismuth cell line films. One is pristine cell line thin films on H2O and H2O different planes 100 and 110. And the other set of H2O is from bismuth cell line films of substrates. The parameters which we have. And now for chromium doping, chromium target by giving supply of 20 seconds. Now this is the Raman data. The Raman spectroscopy shows the three pronounced peaks for bismuth cell line. For chromium to sample, the peak coefficient doesn't change between while in the electron similarly, the HRX data of bismuth cell line is so highly oriented around the CXC, and most of the peaks correspond while in chromium to sample during and for the determination of chromium from the called vacuum system, in which we can clearly see two data. One is for pristine and other one is for chromium to bismuth cell light. And here we clearly see there is no signal of chromium, while after light turned out to be 0.18. Now these are the XPL data for determining its chemical composition. We have performed the from where we can found the spin orbit coupling of 5.3 where found the proteins of three oxygen.
are all in this. Now this is for the chromium or both substrates are shown in this figure. The fitted value, fitted binding energy values are can be seen here. Now this is the transport properties to pure business selling increase on pure and chromium group on S2 substrate one and S2 are top sensors and in from behavior. And for the samples experience for the chromium group for cyanide sample, the monotonic experience the temperature decreases reveals typically. Now this is the MR data for S1 and S2 adult and clearly it can be seen this, what picture we can do to this for coming to selfie market of samples S3 and S4. It is clearly seen in this figure in short magnetic field length at higher magnetic value an effect. Now, this is the network of morpho symptom and these parameters for all these films and alpha value for undoped sample different for two system. Now this is the conclusion. We have successfully deposited bismuth cyanide chemical to negative SU 100 state. We have chromium in bismuth cyanide by the post-patent process. Characterizes shows the effect of chromium on bismuth cyanide chemical from RPS chromium large area to potential for industrial applications with cost effectiveness. Thank you, Ranjit. So this is the end of this technical session one. Remaining two talk, oral talk will be held in this session. We can have a lunch.
Thank you, sir. As we conclude this session, I request Professor Yogendra Kumar Gautam to kindly felicitate our session chair by presenting them plant sampling, memento, and shawl.
आईटी हो गई, कोई बात नहीं सर। अरे बच्चे कहाँ हैं? दोनों पीछे जा रहे हैं लंच के लिए। जी सर ठीक है, आप सभी लोग सर लाइव चल ही रहा है आपका भाई। थोड़ा लंच बारी बारी से ले लो दोनों भैया। हेमंत का सामान कहाँ रखवाओगे? आप लंच ले लो, आप लंच पीसी में डाल लेना आपका तो। सर सर गाड़ी कहाँ है? गाड़ी तो उधर, हेमंत तेरी कहाँ है? सुनो सर, सर के पकड़ो और सर जहाँ के वहां तक पहुंचना है। आ जाओ हेमंत जी के साथ जाओ, ठीक है। ये सामान लेके जी सर मैं जा रहा हूँ। जी भोजन हो गया? कर लो ना आप कर सकते, मैं तो करूँगी, मैं थोड़ा सा चला